Okay, let's see. With this microwave circuit board, with the following problem. 2 of the transistors were faulty. Here they aren't showing any value. On the multimeter diode scale, the transistor that goes here is Q33 and Q35. This one that goes here, and the second that goes over there. This transistor is responsible for turning on the board. It delivers power to the microcontroller. Yes, so it's responsible for providing the voltage to the microcontroller, or is related to that part. This transistor is responsible for activating the relay. This relay activates the high voltage transformer, and it also activates this other relay, which is activated when this board is powered on. So, the problem is, this transistor is damaged, as I said, so the board doesn't turn on. The transistors, I've removed them. So let's measure. Okay, the one that was here. It's a transistor with the marking code NE. This one is that I have replaced with another with a different marking code 1K. But the one that should be here is NE. So let's measure the damaged transistor. I am zooming so you can see the marking code, but it's NE because I don't think. Can you see it? Let's see. I wonder if can you see it? I think you can see it there. Well, I don't know. So, let's measure it. With the multimeter in the diode scale, the only pin on a side of the SMD transistor is the collector. So let's see. Collector base, nothing. Collector emitter, nothing. We swap the test leads. Collector base, nothing. Collector emitter, nothing. And between base emitter, nothing either. So it's bad. It's damaged and it's to be replaced. After, check if that was the problem with the board. In this case, that's the problem. I knew it. So let's measure the other transistor, which is printed P5. Just so you know, the SMD printed codes means you have to work with an SMD catalog, which I'll be posting on the members blog. Emitter base, nothing. We swap. Emitter base, still nothing. Now collector base, still nothing. And collector emitter, still nothing. We swap. Collector emitter, collector base, still nothing. So the transistors are damaged. If we don't have the exact replacement, the same transistor with its part SMD code, what we can do is find a similar replacement. In this case for the NE, I've used the 1K. The 1K has a collector current of 500 milliamps, and the NE is 0.7 amps. That is 700 milliamps. But the collector emitter and collector base voltages are higher in 1K, so they're similar. That's what it's about, right? We can do the substitution. In this way, the current is a little lower, but we can do like this. Assemble it and observe the behavior, because when the manufacturer designs them, in the currents there are always a margin of tolerance for security reasons. Let's measure it now. Let's subscribe and like this video if it's helped you. So now, let's go other detail I want to tell you before assembling this transistor. And it's the following. There are rare cases in which we don't have access. The transistor's reference, it has been erased or destroyed in the worst case. So in those cases, we can draw onto experience, right guys? Based on previous experiences, for example, in this case, I know of previous repairs on this microwave model. On the identical circuit boards, where these transistors are mostly switching and regulating, and some are SMD digital transistors. That's one clue, one indicator. The other indicator would be to measure the voltage across the transistor, but that's not definitive either. I'll tell you why. That was the main reason I was motivated to make this video. So, let's measure the voltage of this transistor. Collector base -2. It's oscillating. We'll put -1.3. In the worst case. Collector emitter -4.6. Now base emitter -2. It is in stable measure. We'll say this goes from -1 to -2. And collector base -2.2. It's also oscillating. Let's say -2.4. Okay, let's activate that transistor, giving it some time. Collector emitter -4.6. Same as. Base emitter. Here it changed. -0.68 negative. And collector base -3.2. With this data that we have measured in the transistor connections on the board, some people say, okay, so between collector and emitter, I got a voltage of -4.6, meaning there's a voltage like this. Base emitter I got a negative voltage, meaning there's a voltage like this here, between 1 and 2 volts. And besides that, when the transistor is activated, I got 0.6. So from this they conclude that this is a PNP transistor, and therefore we could install a PNP. What do you think about? Let me know your opinion in the comments. This reasoning isn't entirely correct because the transistor that's actually needed is an NPN transistor, which is the reference transistor, P5 in SMD code. It's an SMD transistor, and it's an NPN transistor. The arrow isn't pointing inwards. That's the main clarification I wanted to make, and what motivated me to make this video, for you to know what we might conclude about this. The voltages in a transistor or component aren't always there going to tell me or indicate the type of transistor. And this is an example we could do when we don't have the transistor's reference in a more complex circuit. Well, we simply wouldn't be able to know. The only way would be to have the PCB schematic or circuit diagram. Or get another board of the same model and take the component reference from there. However, it's practically impossible with voltages unless we have the schematic, and the schematic tells us the voltage in the such component pins should be. It's the only way when we have complicated circuits. Okay, why is that? Well, I saw in a YouTube video that they do it in this way incorrectly, so it's important to know. The worst that can happen, the transistor could get damaged, or that it doesn't perform any function, or doesn't perform the expected function in that circuit. Here, right in the center, is the transistor 1M. I don't know if you can see it. Can you see it there? I think so. This will be the replacement for the P5 that was on the board, because it's very difficult for me to find the exact same transistor right now, so I'm going to make this replacement. Whenever you replace a transistor, make sure it at least has the same voltage ratings, both the collector emitter and the collector base. For example, in the 1M, the voltages are similar to the P5 transistor. Even the collector base voltage in the M is 60 volts, while in the P5 it's 40 volts. And also note the collector current, which in this case is the same. The only difference may be the purpose of the transistor. While a transistor is general purpose, like the 1M transistor, whereas the P5 is a high-speed switching transistor. Okay, let's measure this transistor to check if it's good. This is the 1M collector emitter. Doesn't show any reading. Collector base doesn't either. Between base and emitter it's showing reading. But not in the opposite direction. It's good, doesn't show a reading. Collector emitter shouldn't show a reading in the opposite direction either. Remember, this is an NPN transistor. Such base is positive. Let's solder the transistor. Here goes this transistor. A little bit of soldering paste, and we'll put it in place. I'm going to use the soldering gun. It's the only thing I have right now. So, if you have a good quality soldering iron with temperature control would be best for SMD soldering. But we'll have to make do with we have on hand. There's the collector. And we're going to finish by soldering the base and the emitter. We'll retouch the base. Okay, there it's. We press it down to make sure the base is properly seated. Okay, now we clean it up a bit.
Isopropyl alcohol is preferable.
So we also need to check the paths aren't short-circuited. After soldering, let's check the tester leads are good. Okay, first check the collector isn't shorted with the emitter. It's good. And the collector isn't shorted to the base either. Here it's showing the transistor's collector base value. In the opposite direction, it shouldn't show a reading. It's fine. And base emitter shouldn't show a reading either. Unless in the other direction. It does. So, okay guys, the transistor is installed correctly. It would also be good to check if, measure this by means of another point, that is to say, using a point on the same path but at a different tin solder point. For example, here at this point corresponds to the emitter, and find another point that corresponds to the base and measure there to see if the transistor pins are soldered correctly to the circuit pad. So, that's also good practice. Verify, thus, the transistor's pins must be making good contact with the path, the base, with the collector. Yes, it's soldered well. Okay. After mounting the board, something strange happened. Now it power on by itself. No, just kidding. If I connect the board, the relays don't activate anymore. So I'm going to show you what's happening. I connect it again. 10 seconds. Start. Start marking the time. and we could see that the relay doesn't activate. The multimeter or tester is connected to the two relay pins on the 200 ohm scale. Right, then, it timed, but the relay didn't activate. I've checked all the components on the board that I can measure. The only thing I suspect the problem might be in this part of the circuit, where this transistor is located. So, let's focus on that transistor. It's responsible for activating, or is related to, the relay circuit. If we look at the path going to the base of this transistor, there's a component marked in PCB like C35. It's a ceramic capacitor with a color code. Let's see if adding a high resistor in parallel can activate this transistor. So, let's put a 10K resistor together with a ceramic capacitor to see if we can activate this transistor, which, as I said, is responsible for activating or is related to the relay circuit. Again, I connect the tester leads to the relay pins on the ohm scale, and we'll connect the power. Here we've the display at 0 seconds. And if I put the 10K resistor on that capacitor, let's see. One of the relays activates, which is the relay for the microwave fan and light. So now let's set a time seconds. The timer starts counting, and we put the resistor on the ceramic capacitor pins, and it activates the relay. Let's solder it to see better. There we have it. We hear the relay click activating. This is the relay for the fan and light. If I set a time of 20 seconds, the main relay of the high voltage transformer activates. Here we've it, and indeed we see that the relays are activating with this resistor. So we're going to leave it permanently attached to this capacitor. We'll solder it in place. Let's check the board's operation to see how well it works. I'm doing to verify it, so you can see, right? It's absolutely true. All you learn is always, that's the purpose of this YouTube space. This connection that I've made is a bypass that corresponds to the door micro switch, and it has been bypassed in such way it allows the relay to activate. Otherwise, the relay wouldn't activate, because that type is due to safety regulations. So another connection I'd made to the PCB board is the AC power supply cable, which are these two lines. The polarity doesn't matter because it's alternating current. In this case, it's an AC transformer. These 2 points corresponds to this pin and this other connection pin. Okay, so these 2 pins are for the AC line input, and these 2 here are for the door switch, and this one is to activate the fan as well, the lamp. So we're going to connect it like this, and I'm going to place the tester probes in the main relay. Okay, let's connect it. The relay still reads open in tester display. Let's set the time to 20 seconds. And the main relay closes. This is the relay that activates the high voltage transformer, which is responsible for sending the high voltage to the high voltage circuit. This circuit consists of a high voltage capacitor, a high voltage diode, and a magnetron. Okay, already here it's working. Another thing that would be good to measure: the other relay. The one that activates whenever we energize the board. This other relay is connected to the AC line voltage and powers the fan and lamp. So let's connect it. As soon as I connect it, this relay activates, sends a voltage from this pin, this I'm pointing, and this other pin. Yes, it's activating just now. That circuit is working. Fine, that voltage is supplied for this tiny relay here. For the lamp and the microwave fan, and the high voltage transformer relay. These are the main drive relays on this board. I remind you, please be very careful with the high voltage capacitor. Always make sure it's completely discharged, and avoid hot working on the high voltage circuit, as it's extremely dangerous. You are exposed to a real danger of death by electrocution. This is serious. This is real. It's very, very dangerous. I see you soon on the next video from Resistor Alvistec.